Welcome back to Through Inquisitive Kids. So in this lesson, we are going to be learning about the expressions of linear functions. Chapter 4. Accurately find the relational expressions to linear functions. This is part 1 of the lesson Applying Linear Functions. Parts 2 and 3 will be following after this video. So if you would like to be notified for that, please click the subscribe button down below as well as the notification bell so you will be notified when we upload that video. Learning goals. Determine the relational expressions of their corresponding proportional functions and determine the relational expressions of their corresponding linear functions. Introduction. Before we learn about the graph and properties of proportional functions, can you write two relational expressions of a proportional function, and how would you graph them? Well, here we have two functions right here. The 2-point method. 2 points determine a straight line. So think, versely, if you're given 2 points of a linear function, can you write its relational expression? Determine the expressions of proportional functions. Introduction. As the ball slides down a hill, the relationship between its velocity, v, which is meters per second, and its slide time, t, which is in seconds, is shown in the figure below, or next to it. Write down the relationship between v and t. And also, what is the speed of the ball at 3 seconds of sliding? I want you to pause the video and try to solve both of these questions on your own. Well, v is equal to 2.5t because, as you can see, there is no y-intercept and the slope is it's going at 2.5. V is in 2.5 times t is equal to v. And when it says 3 seconds of sliding, well, we know that's just substituting in a constant for t. So we can replace t with 3, and we have 7.5 meters per second. Example 1. Find the relational expression of proportional function y is equal to m minus 4x to the m squared minus 15 power. Well, first, using the definition of proportional functions, we know m squared minus 15 is equal to 1 and m minus 4 is not equal to 0. Therefore, m is equal to negative 4. Why does m squared minus 15 have to be equal to 1? Well, since it's a proportional function, the power of x has to be equal to 1. And its coefficient must not be 0, so m minus 4 cannot be 0. Therefore, m can only be negative 4, meaning that y is equal to negative 8x. Method summary. Use the definition of the proportional function, so use its definition, to determine its expression. The index of the independent variable is always 1 and the coefficient cannot be 0. Think, how many conditions are needed to determine the expression of a proportional function? And what about a linear function? Well, you need only one condition to determine the expression of a proportional function, and that is k, or its slope, because we know in proportional functions b is equal to 0. But for a linear function, you have to have 2, because you need to both know the k, slope, and the b, y-intercept, in order to write its relational expression. Determining expressions of linear functions. Example 2. Given that a proportional function passes through the point 0, 5, this should not be a proportional function. This should be linear. Let me change it right here. Linear, because we know a proportional function cannot have a y-intercept. So given that a proportional function passes through these 2 points, find its relational expression. Let the expression of this proportional function be y is equal to, okay, so all the proportional functions here would be linear function. Yeah, I know that's confusing, but it's linear function. That we made a mistake while typing this up. So this is y is equal to kx plus b. So we can substitute these coordinate pairs because we can also think of these coordinate pairs actually as solutions, possible solutions to this function. So we can think of negative 5 is equal to 2k plus b, So b is equal to 5. Solve b is equal to 5 and k is equal to negative 5. Now that we have the slope and the y-intercept, we can write the relational expression of this proportional function, which is y is equal to negative 5x plus 5. Let's do some practice. Given that straight line L is parallel, I think in one of the previous videos it talked about the significance of this word, is parallel to line y is equal to negative 2x and has a y-intercept of 0, 2, find the relational expression of L. Well, first we know this function has a y-intercept, meaning that it has to be a linear function, not a proportional function. So we have the y-intercept, or b, down, but what about k? But what in here tells you or hints at k? That would be this word parallel here, because parallel means their velocity, their increasing speed, their slope is the same. So all we have to do is look at the slope of this function, which is negative 2, and we know that for this straight line L, its slope is also negative 2. Therefore, its relational expression would be y is equal to negative 2x plus 2. Any single time you solve problems like this, I want you to go in with the mindset of what is k, what is b, what in the problem hints at k and b, and now that we have k and b, how do I get the relational expression? Example 3. The graphs of a proportional and a linear function are shown. Their intersection point is at point A, or its coordinates are 4, 3. B is the y-intercept of the linear function, and OA is equal to OB. So here, OA is OB right here, so this is double the length of OB. Find the relational expressions of the proportional and linear functions. I want you to try to pause the video and see if you can solve this problem on your own, and then we're going to come back and talk about it. Let the expression of the proportional function be y1 is equal to k1x, and the linear function be y2 is equal to k2x plus b. Point A, 4, 3, is their intersection point, meaning that this is the common solution to both of these functions. It works in both of these linear functions. We can substitute this coordinate pair into the functions, which we get k1 is equal to 3/4, which we get k1 is equal to 3/4. Therefore, the relational expression of the proportional function is y is equal to 3/4 of x. Since OA is equal to the square, so we can think of this as a right triangle, meaning we can apply the Pythagorean theorem. So OA is equal to the square root of 3 squared plus 4 squared, which is equal to 5. And since OA is equal to 2OB, we know that OB has a length of 5 halves. Point B we know is on the negative half of the y-axis, meaning that the coordinates of B would be 0, negative 5, 2. Because OB, this is its length, but since its length, it could be positive or negative. But since we can see that it's on the negative half of the y-axis, we know the coordinates of B is 0, negative 5 halves. Also, because B is on this linear function, y2 is equal to k2x plus b, b is equal to negative 5 halves. After substituting this into 3 is equal to 4k2 plus b, we get k2 is equal to 11 over 8. Therefore, the relational expression of the linear function is y2 is equal to 11/8 x minus 5 over 2. Exercise. The fuel tank of a certain tractor can store 40 liters of fuel. After filling up the fuel and starting to work, the relationship between the remaining fuel, y, in liters in the fuel tank and the working time, x, in hours, is a linear function. The graph is shown in the figure. First of all, find the expression of this linear function. And 2, how many hours can a tank of oil last for a tractor? I want you to pause the video and see if you can answer these two questions on your own first. The expression of this linear function. We always start with the form y is equal to kx plus b. Now all we have to do is plug in k and b. So what we can see here is b, which is the y-intercept, is 40 because we know that it starts at 40. You can see that. Its slope, first of all, since it's decreasing, we know it's a negative number. And for every increase of x, y increases by 5. So we know that it is negative 5x. That is the slope. Now, whenever looking at these problems, it's always important that you're paying attention to the intervals that these axes are increasing by. Because if you don't look at these, you might just assume it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. But it's really 10, 20, 30, 40. So that always makes a difference. And 2, how many hours can a tank of oil last for a tractor? Well, this is asking how many hours can this tractor run until it has no oil left? That would be 8 hours because in this case that is the x-intercept, which is 8. So here's our conclusion. The method of determining the expression of the linear function according to its graph is first select the two known points from the graph. Then we can substitute the x and y coordinates of these 2 points into the set expression y is equal to kx plus b to obtain the undetermined coefficient, which is k and b, thus finding the expression of the function. Example 4. Within its elastic limit, so its range that it can stretch, the length y in centimeters of a spring is a linear function of the mass x in kilograms of the object hung from it. So imagine let me draw this out, a quick sketch. We have a spring, and then something is hanging from it. The natural length of the spring is 14.5 centimeters. When the mass of the object hung is 3 kilograms, the length of the spring stretches to become 16 centimeters. Find the relationship between y and x and the length of the spring when the mass of the hanging object is 4 kilograms. It's asking for 2 things here. First, the relational expression, and then a certain coordinate pair. So the first part we can do easily. Let first it be y is equal to kx plus b, where k is not equal to 0. From the problem, we know the natural length, b, is 14.5, and 16 is equal to 3k plus b. Because in this case, it gave us, so here, you'll see that in many problems like this, it gives us a specific scenario. Keyword here is when. So from this specific scenario, we know 16 is equal to 3k plus b, where we're substituting in the values of x and y for this particular scenario. Solved, we know b is equal to 14.5 and that k is equal to 0.5. Then we can plug these 2 values back into this original equation. So when it's within its elastic limit, we know y is equal to 0.5x plus 14.5. So now we're trying to find the length of the spring when the mass of the hanging object is 4 kilograms. All we have to do is substitute the value of 4 in place of x, and we get y is equal to 16.5 centimeters. Therefore, the length of the spring when the mass of the hanging object is 4 kilograms is 16.5 centimeters. Now we have another conclusion. To solve this kind of problem, we must first establish a mathematical model, which is this first step right here. Let y is equal to kx plus b, where k is not equal to 0. A mathematical like that, according to the given conditions, in order to obtain the functional relationship or relational expression. Class summary. Today we learned all about the expressions of linear functions. The proportional function, which is y is equal to kx, with k not being equal to 0, and the linear function, y is equal to kx plus b, where k is not equal to 0. And we did many problems where the general steps were to first set the expression, which is one of these. And then, out of the specific scenarios given in the problem, we would substitute in x and y, or k and b, in order to obtain the final relational expression. And then using that, we can substitute in specific values of x to get their corresponding y values, or the other way around, using the y values to find their corresponding x values through this relational expression. The two skills we learned today is to determine the relational expressions of corresponding proportional functions and linear functions. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.